Good day everyone, I am Bernafe Abilia and my lecture video is all about the surface in upper air charts. In the first slide of my presentation, you can see my learning objectives. And if you notice, I only have 3 learning objectives for this topic. The first learning objective that I have is to understand the movement of the wind and its direction. Second, be able to know the difference of surface map and upper air map and its significance. Third, to know what are the forces that affects the wind direction. In the second slide of my presentation, you can see a map, a surface map to be exact, in which the large blue H on the map indicate the center of high pressure or the anticyclones, while the large red L's represent centers of low pressure or the mid-latitude cyclonic storms or depression. If you're wondering why low pressures are mid-latitude cyclonic storms rather than the high pressure, it is because when the air pressure is low, it will give chance to the air to freely rise into the atmosphere where it cools and condenses. And that process will produce rain. And we all know that. And this is why when weather reporters tells us that in that particular area has low pressures, they advise the people to bring umbrella with them because rain often follows. And the third slide of my presentation, it shows the upper air map and 500 millibars. Notice in the map that it has trough and ridges, and those red broken lines are the isotherms or the lines of equal temperature. The solid black lines are the contour lines, and if you notice, the wind direction is parallel to the contour lines. And those violet arrows indicates of where the wind blows. In ridges where the air is warmer, noticed in the upper air map, the trough and ridges forms a wave, right? It forms a wave in which the troughs are lower and ridges are higher, as you can see. This will relate to the phrase warm air rises and cold air sinks. Did you get my point, class? Alright. The point is that in ridges, the air are warmer because of the constant pressure rises in warm and less dense air and lowers in cold, more dense air, which indicates the troughs and ridges. Also, the warm air alofts is associated with high pressure and cold air alofts is associated with low pressure. Isobaric map shows height variations at a pressure level of 500 millibars, while the contour lines, like what I've discussed earlier from the previous slides, it is the lines or the solid dark lines on the map and also the lines that connect points of equal elevation above sea level. And have you noticed the difference between the two maps? The surface map and the upper map. As you can see at the surface map, it has only few lines in it. It has a few lines in it, while the upper air map has a lot of lines. It is because the surface are plotted on a map of constant altitude, while the upper air map or chart are plotted on maps at constant air pressure. That is the difference between the two maps that I've shown you. Okay, let's proceed. In this slide, you can see the two figures in which figure 2 shows a column of air where warm, less dense air lies to the south and cold, more dense air lies to the north. In the area shaded gray, notice in the area shaded gray, at the top of the column, it represents constant pressure or the isobaric surface, where the atmospheric pressure at all points along the surface is 500 millibars. Have you noticed in figure 2? The warmer air in the south, a pressure reading which is 500 millibars, is found at a higher level, right? It is found at a higher level than the 500 millibar. while in the colder air in the north is observed at a much lower level. Can you spot the difference between the two from the south and the north? Okay. The variation of height in 500 millibars constant pressure surface are shown as a contour lines. These are the contour lines. Although contour lines are height lines, keep in mind that they illustrate pressure in the same manner as isobars do. In many instances, the contour lines on isobaric map are not straight. Notice in figure 3, the lines there are not straight. The contour lines are not straight. And the contour lines also appears wavy, just like what I've shown you from the previous slide. Alright? Okay. To relate the change in altitude of isobaric surface, that is why not just all contour lines comes out straight, but contour lines are these sometimes are wavy, just to relate the change in altitude of the isobaric surface. Forces that affects the horizontal movement of air. So this is the last slide. As you can see, that there are 4 forces because change its direction requires the action of an external force. And also this brings us to Newton's second law, in which it states that the force exerted on an object equals its mass times the acceleration produced. This could be written as force equals mass times acceleration. Acceleration is the speeding up and the slowing down or the changing of direction of an object. Therefore, to determine in which direction the wind will blow, we must identify and examine all the forces that affects the horizontal movement of air. And that forces is the forces that appears in your screen. And the first force is the pressure gradient force. It is the force that results when there is a difference in pressure across a surface. Second, the Coriolis force, the invincible force that appears to deflect the wind. The third force is the centripetal force, the apparent force in a rotating system. And the last force is friction. It decreases the wind speed, also changes the direction of the wind. Okay, so to sum it up, the overall or the purpose of this mini lecture is to give an insight for the future lessons that will be the lessons that will be next to me for the future lessons, and to give you knowledge about the purpose of this map and chart, and how these two help us understand why we have these windy days or rainy days. Because if you recall in my discussion, I had talked about the low pressure in which it sometimes produces rain, right? Right. And if you noticed, our weather system is not the same from particular regions or areas, mainly because of our geographic location. So this mini lecture is all about the wind direction or movement that was being shown in the map. And we have 2 devices to help us locate the wind direction, with which are the surface map and the upper air chart. So that's end my report. Thank you for listening, and I hope you gain something from it. Bye.